Oh, I heard. All right, we're going to get started. So good evening and afternoon and morning and whatever time it is when you're watching this, for those online or watching the recording. This is the July, wow, the year's gone by fast, meeting of July 2026 meeting of the St. Louis Java User Group. I'm Zachary Klein, one of the steering committee members, and I'll introduce you to the rest of us as we go forward here. And so I'm just going to dive right into our intro. Our user group has been around for a long time, since 1997. OCI, which is the company that I work for and that provides the space for us to meet in, was one of the founding partners for this user group. Attendance has always been free. It will always be. There's no formal membership list. We do have a meetup.com website, which we'll give in a minute here, and folks can stay in contact with our group through that. We typically meet on the second Thursday of each month, but there is a little bit of flexibility there depending on when speakers are coming through. And we typically begin at 6 p.m. Central Time, food and social, and then our program begins close to 6:30. And we typically meet here. So congratulations, you have made it. This is the training room here at Object Computing, and there's a number of user groups in the area that meet here, including the Java User Group and a few others. So we're very grateful to OCI for their hospitality. Our steering committee, okay, this photo is out of date. We need to get one with our latest edition. So Zachary Klein, and then Bruce Allspaw, Robert Levitt, who's here in the front row, and Ted Doyle. Ted and Robert are both remote. And Asha, I'm sorry, your last name? Okay. I'll get with you later and nail that, I promise. She is our newest member of the steering committee and in the St. Louis area, which we're very happy to have more St. Louisans helping out with the steering committee. So, oh, there you go. Asha Somayajua. Is that close enough? Okay, I'll work on it. I default to Spanish pronunciation. I know that's not correct, but that's just what I'll work on it. All right. So we do want to thank our sponsors, as I already mentioned, Object Computing. Full disclosure, my employer. Also, Manning and JetBrains have been longstanding sponsors of the user group, and they sponsor a lot of user groups. We're very grateful for them. And then our friend Lee Bobbitt has been sponsoring our Meetup subscription. So we're very grateful to Lee for that. A couple of announcements. The Kansas City Developers Conference, that's coming up September 9th through 12th, kcdc.info. And then we have a Manning JUG discount code. I think that's the same code we've had for a while now, 45% off. So we're very grateful again to Manning for their generosity. All right, so tonight, ooh, I'm getting an echo here.
Oh, hell. Just a second.
Okay, yeah, if you can mute yourself, Robert. All right, so tonight, August 13th, we have our, no, I'm sorry. It's been a long day, and I've been behind an AV rack for a while. So that's next month meeting is in August 13th. Is going to be James Fredley from North Carolina speaking on Apache Grails, which is a topic we have not heard in quite a while. So that's going to be exciting. We are still looking for speakers for September and October. And then we have our November presentation there. Can I scroll down here? I guess that's all there is there. Eric DeAndrea from IBM on testing AI-infused applications. So some very interesting presentations coming up. Again, please stay tuned to our Meetup page, which you can see here, meetup.com/gatewayjug. That's essentially our website. We are working, I think, on a more official website that'll be standalone. But for now, the Meetup page is where you can learn about the JUG and what we have going on. And then all of our presentations are recorded and uploaded to our YouTube channel, which you can see there on the slide as well. And if you are at all interested in giving a presentation or sponsoring or participating in any way with the user group, you can give us an email at the googlegroups.com address there at the bottom of the slide. Let's see, before we go into tonight's presentation, Lawrence, you were going to give us a little pitch for what you got going on?
Yeah, I'm the organizer for STL Tech Launch. It's a casual meetup where we meet at a local, great, reputable restaurant and just, hang out, eat lunch together, talk about tech or, normal stuff like cats or the weather. So you can find us by going to halo.group/tech-lunch. This month, I guess next month actually, August 1st, we're going to Golden Chicken in St. Peter's, 11:30 to 1 on August 1st. Anyone's welcome. Feel free to show up.
So it's halo.groups
halo.group, singular,
Halo.group/tech
-lunch.
-lunch. Tech-lunch. All right, cool. So, and the next meeting is August 1st.
Yes.
Is that a regular time or is it just kind of scheduled as you go?
It's approximately every 4 weeks.
Okay. Very cool. All right. Well, for tonight's presentation, and I should also say also our food sponsor for this evening, so thank you for that as well. Sam Gammon, got that right? Okay, is going to be speaking on Elide? All-in-one native tooling for the JVM. I'm excited on this topic, so Sam, take it away.
So, hello everybody. Thank you for having me. It's very nice to be here in St. Louis. And I'm going to tell you a little bit about a project called Elide that has been in the works for several years now. With AI changing everything, all of the rules are going out the window. And what Elide is meant to help us with is to sort of bring Java into a new paradigm of development. We are Java enjoyers and fans. We run on JVM. We build this software with Kotlin and Rust. So the software is itself written in Java and Kotlin. But really what I'm here to show you is sort of a new methodology of working with your software, where previously we had a JDK and a JRE, and the JDK comes with a compiler and a runner. Now this is just one binary that has everything built in. So I'm going to show you that in just a moment. Okay, let's, is that gonna work? Is somebody in the meeting, can somebody confirm that the presentation is working? Are you in the meeting?
I'm able to see it.
You're able to see it? Okay, good, good. So, Elide is one binary with many languages in it, and I'm gonna show you all about it. First is the concept, which is that I'm a lifelong backend developer. I've done Python, I've done PHP, I've done Java, Kotlin, I've done Swift on the back end, JavaScript, TypeScript, so many. I've spent years as a Pythonista before I graduated to Java. And the methodology of development in each of these areas is pretty different, right? You have Maven, and you have your compiler, and you have your Gradle in Java land. Over in Python, you have PyPI. In Node, you have NPM for installing dependencies. And what we noticed was that Node was really effective. People were just adopting it for about 10, 20 years. It just ate Java's lunch, everybody's lunch. And this put a chip on my shoulder, frankly, because Java's great. And why is Node eating it alive, right? The answer is because the methodology they have is really lightweight. And so this company, this whole idea is to bring that methodology to Java too. So toolchain sprawl is the problem. And this is that most applications these days actually end up being polyglot. Even if you're developing in Python or Java, you very often have to write some JavaScript or some TypeScript too if you're doing anything on the web, if you're doing anything on like web-based mobile, right? Like eventually you're going to write some JavaScript. And this is where Node has a real advantage today, is that if you're a Node developer, you can do your backend and your front end all in one language. You can share objects and all sorts of other things very easily. What we've done is we've taken all of these tools and put them into one. And so the new methodology I'm talking about here is it's closer to Node, where you Elide install to grab your dependencies, you Elide build to compile. It has a test runner built in, so you can run your tests right there without installing anything else. You can format code and you can run code too. And this replaces all the tools on the right? Like instead of npm install or pip or Maven, that's all, and I should say Elide install does cover all three. So you can install npm dependencies, Maven dependencies, and Python dependencies all in one. This replaces your build command and your test command. And all of these frameworks, right, just sort of disappear. At least that's the theory. So a bit about like architecture here. Actually, I think this would probably be a pretty warm crowd for GraalVM, right? Has anybody heard of GraalVM? Yes, a few people, cool. So GraalVM is a sort of a lab's experimental implementation of a JVM and several other things. Like it's a big package that Oracle makes. So there's several components in GraalVM, and to clarify, we're a truffle-based runtime. So truffle is a language interpreter that can be amended or adapted to nearly any language. Truffle can run Python, it can run JavaScript, it can run Java, bytecode. Native image too. Who here has heard of native image? Yeah, okay. So some people. Native image converts a JVM bytecode program into a native program, right? So instead of there being a JVM that you invoke with Java and class path and so on, you just get a binary, and that's what you're calling, just like Python or Node or anything like that. So we take a GraalVM base with truffle, right? And this means it doesn't matter how many languages you use, there's only one heap, one JIT, one garbage collector. And then the languages are on top of that. And then all of the developer sort of experience is on top of that. This yields some serious gains. So immediately, your Kotlin compiler gets 35 times faster. Your Java compiler, 20 times faster. CPython just running code is 4 times faster, right? And here's the thing. It would be so funny if Java got the last laugh, right? But it turns out that Java can run Python way better than Python can. Java can run JavaScript way better than JavaScript can. It is such a great substrate for these things that actually putting the languages on top of that is a winning strategy. Lots of, by the way, people in this room may remember Nashorn and JRuby and and Jython, sort of all this prior art that didn't quite get there on the performance side. Those are all valid lessons, but now we've fixed those problems. By the way, comparing it to JavaScript is like bringing a nuclear weapon to a slap fight. It's like 75x, right? So this benchmark, by the way, is just express.js. It's a framework in JavaScript that's like Micronaut, or it's a web framework. And we take express.js with identical code and run it on top of Netty instead. And that's it. You do that and you get a 75x gain in server performance, right? So this is why we all bet our careers on Java, right? Is because it's a workhorse. So I'm going to show you a few demos about how this works and sort of poke around with it in front of you for a moment so you can see how you use it. In particular, because this is a native binary, all of the performance gains that we see we're getting from startup time, because the JVM takes a few seconds to start up and then many seconds to warm up all the way. Instead, what you're getting here is immediate startup and basically like 60–70% of the performance, but it's immediate, right? So you would almost think about it like a really heavy gas engine car versus a light electric car, right? The light electric car is not going to go as fast in terms of top speed, but when are you ever at your top speed, right? The acceleration, the cornering, all of those things matter too. So here's a benchmark, and this is partly how we prove our performance gains. It's a little small, so I'm going to read it for you. But here, we're benchmarking running a JavaScript versus Bun. Very quick, who here has heard of Bun? Okay, so for those who haven't, Bun is an alternative Node runtime. And they just rewrote it. It's a brand new, basically, runtime that's much more modern than Node.js. And so that's the one that we should benchmark against, because if we benchmarked against Node, it would look really good. But that is the state of the art in JavaScript is Bun. Bun starts up in 9.7 milliseconds, which is very fast, no question. But Elide starts up in 5.2. That's like half, right? Then we've got Java here, and actually I'll come back to that one. Here's Python, and Python starts up in about 10 milliseconds. Elide starts in 5.3. So there again, it's half the startup time of regular Python. The big one, though, is the Java compiler. This is the one I want you guys to see, because normal Java compiler is about 300 milliseconds. And this is just to start up the Java compiler and compile a hello world. One class with a simple main function that emits hello world. We do that in 11.5 milliseconds. And that gap grows the more code that you have to compile. Obviously, we're all building more complex things than hello worlds, right? So where does it converge? It turns out it converges at 10,000 classes. In other words, in one sitting, if you're compiling 10,000 classes from nothing, then you should be on a JVM compiler because it will be optimal. Anything less than that, which is, I'm just going to guess, is all of us. I've done a lot of Java work in my career. I've almost never compiled 10,000 classes at once, right? Lots of those classes are in jars that are already built, right? Incremental builds, build caching like Maven and Gradle have put you further away from that goal, right? So our theory is that most of the time, your Java compiler is operating suboptimally. And it has been forever for everybody in every project. And when you native compile it, you get a different performance dynamic entirely. In fact, we have a benchmark which benchmarks the Java compiler giving its version, so Java C -- version, versus us doing a full compile. And that's apples and oranges, right? But it's an important benchmark to show that actually we can return to you with your compiled code before Java even gets its boots on in the morning, right? It's still like booting up and printing its version. So, and these benchmarks, by the way, are replicable. You can do them on your machine. I can do them live for you if you want to see them. So what does this look like with a more complex application? Here we've got a Spring Pet Clinic sample, and I'm going to pull up this GIF so that you can see it in detail here in a second. But it's going to restart, and I'm going to narrate. There we go. So here we do a Elide install. That installs all of our Maven dependencies. This is very fast. This is not sped up. Right, 5.2 seconds. Elide build, that's already done. 71 milliseconds is what it took to compile. And there it just ran a Spring app. So in less than 10 seconds, you have a brand new app, never seen it before, download all the dependencies, compile it, and run it, which is unthinkable to a Maven and Gradle developer. Like, this is an unthinkable thought, right? Gradle's never this fast. So let me pull up the GIF for you guys so you can see that. 1 second. That is a great question. And the answer is yes, it does. In fact, we have a Docker toolchain built into the binary. So Elide can build your Java to bytecode. It can build your bytecode to a native image with native image from Graal. Then it can wrap that native image in a container and push it up to a registry, all in one tool. It's notable too. Yeah.
Does the Guava take a long time to that's always the longest thing to compile on a Spring Boot app.
Exactly. And Guava is an interesting case. Like, I think if you peeled back the Maven structure and just built the code itself, because Java C is pretty fast. Like, if you're just invoking a command line Java C, it's pretty fast, but nobody uses it that way. It's always plugged in through Maven or Gradle as a system compiler, right? And then you've got JIT running on those threads as well as the JVM's threads, and those are competing. They contend, right? And so that's a lot of the performance game too. Yeah. So hold on, I'm looking for this GIF here. You know what? It's in my text with Josh Long. I don't know if you guys know him. Hold on. Along with a lot of arguing. Okay, here we go. There we go. Here. So here is the GIF again, but in full. Let me see if I can restart it too. So just as like before, we Elide install.
The folks online can only see the Spring Pet Clinic slide.
Oh, okay, hold on. I'm just going to share my whole screen here.
Much better.
So this is the same workflow that Node people use every day. If you build JavaScript applications, you're very familiar with this workflow of I'm going to install my dependencies, npm install, then I'm going to run, then I'm going to build. These are all I have these 4 or 5 commands that I use every day, right? And that is different. That is different from standard JVM development. But our whole thing here is if you use this new system, you're going to have a much faster developer loop. Yeah.
Are you still downloading from Maven Central? How are you making the internet faster?
You know, it turns out, you want to know some funny facts? Gradle only speaks HTTP 1.1. Doesn't speak HTTP 2. Nope, dead serious. Not just that, but in 2026, they pool connections based on the IP count of a DNS response, which is absurd because most internet properties that are large these days use Anycast. So they'll use 2 or 3 IPs, not like 1,000, right? And so Gradle will artificially limit your connections on that basis. Gradle also doesn't support Z standard or Brotli, any of the new compression. So the way that we do this is, and it also doesn't support native transport, right? So like ePOL, uRing. So if you do all of those things, if you have fast crypto, fast transport, fast disk, this is what you get. So it turns out Maven can be fast. Maven itself is like Maven Central itself is not slow, right? Yeah. Yeah. Okay, back over here to the slides. Hold on. Oh no. Hope it doesn't tab through everything in my life here. Here. So next demo is formatting Java and Kotlin. So the reason I'm going to show this to you guys because code formatting is a little silly, right? Like it's an afterthought on most teams. But code formatting is a case where a native tool is genuinely 100% a better choice. There's no competition in this space between JVM and native because every time you're formatting code, you're booting up a JVM, you're parsing and emitting strings, and then shutting it down, right? And so code formatting has always been a big headache in JVM. Like you have to add Spotless to your Gradle and then configure the plugins with Spotless for KT format and Google Java format or whatever your formatters are. And then when you want to format your code or even check your code's formatting, you have to start a JVM, right? Which doesn't make sense, say, from a Git hook. Like JavaScript teams, their formatters are fast enough that on commit, they automatically format. So they never think about it, right? They just commit, it formats, and the code that goes up to GitHub or whatnot is flawless. We've never had that luxury in JVM because of this split. And so if I pull up a terminal here, Ghosty. So here I've got Elide on my computer. You guys can all see this, right? So if I do Elide help, we're going to see here so sort of some of the commands that are built into the tool for you, right? We can initialize a new project, get info about Elide, so that'll tell you the version and garbage collector that's active, that kind of thing. You can run programs, obviously that's the runtime. Got an alias there that's compliant with Python. So it's the same arguments you would give Python, just you put Elide in front of it and it's faster. A server, right? So you can serve static files if you want. We have all sorts of like batteries enabled features like this. So, and there are tools like ClassPath here that are meant to work with a regular JVM too. So technically I can do, let's not yet. We should totally add it. Yeah, that's a good point. In fact, I will fire that off to the team momentarily. So we're going to try a Java Hello World project. And this is Elide init. It helps us create a new project from scratch, right? And I can sort of fill out this form and we'll say, hello, St. Louis. And I can tab to see a preview here. Here, let me move this. So this file is what's created for you to facilitate the project, dependencies, declarations, all that stuff. This is a language called Pickle from Apple. Has anybody here heard of Pickle? Pickle is a very rare esoteric thing. But the point is that this feels like Gradle, right? You get enough imperative in your build and enough declarative to functionally make your described build here in declarative form. So I'm going to hit enter, and that should, yeah, create. So now it's going to say, do I want to build this project? Say yes. It's done. Did you guys miss it? 152 milliseconds. It's already compiled. Right, now do I want to run my tests? Sure. Okay, test passed. That's it, it's already done, right? And this, by the way, is JUnit, but native. So part of our thing here is we don't invent new APIs unless we have to. Unless there's an API that doesn't exist, then we'll maybe invent it. But our thing is Elide should be drop-in with the APIs you already love. It's just drop in and faster. We're not ever going to make you change your software. So now do I want to run the project? Sure. Hello, St. Louis, Jug. Cool. So the demo that I was intending to show, though, is code formatting. And I'll actually jump over to Elide's code base itself. Got a lot of Kotlin files in here. Let's see if we can grab a bunch. And then I'll ask it. Let's see how many that was. So we've got 1,348 Kotlin files. 1,300 Kotlin files. Let's see how many Java files. 713, which means we have 2,000 Kotlin and Java files in this project. And I'm going to format them all right in front of you. So there's the Rust and JavaScript, ignore that. And then here's the Elide Java format. That's it. 2,000 files in like less than a second, right? And at that speed, now you can put this in a GitHub. Now you can use it all the time. Now you can use it on save, right? It's fast enough that you can use it all the time and it doesn't even seem like it's there. So that's formatting Java and Kotlin. Now I'd like to show you interop. So I mentioned earlier in our architecture diagram here that we have JavaScript, Python, and Java all on top of this. And Elide can run each of those independently. It can also run programs written in a mix of these languages, which is kind of novel. So you can have a Python program that imports from JavaScript. You have a JavaScript program that imports a Python module. This is true. So I'll show you. Let's jump into a REPL. Right, so if you just run Elide with nothing else, just like Node, you get a read eval print loop, right? I can say const x is 10, x is 10, right? This is real JavaScript, so I can JSON stringify x, right? Now I can switch to Python, and I still have x. So now I can import JSON in Python. JSON dumps. Now I just used a value computed in JavaScript in Python, right? Now there's actually no reason this can't be the truth of how we build software today. The only reason that we can't build software today like this is because JavaScript, Python, interop, all of these languages, interoping is extremely inefficient, right? It turns out if you just take JavaScript and Python and smash them together, it doesn't really work because they both have garbage collectors. They both have JITs. So you'll make an object in the JavaScript side and hand it to Python. Before Python can use it, JavaScript deallocates it because it doesn't think it needs it anymore, right? Yeah.
Yeah, other than issues with garbage collection, what distinguishes or what's like some noticeable distinguishing features about this compared to say a TUI for Jupyter?
Sorry, what?
Compared to say a terminal UI for a Jupyter notebook.
Sure. Not much actually. So this is just a REPL, and it doesn't have any of the persistence of a notebook per se. Like you can't like save a REPL session and come back, right? So a notebook is a lot more durable and typically has like UI built around it, but that is probably the next thing we're building. So nicely done. Yeah, did that answer your question?
Yeah.
Okay. So in this model, there's one JIT, one GC, one heap. And when you do that, when you have the languages as syntax plugins to the one engine, all of those performance issues melt away because now your JIT can actually see across language borders. It can inline the JavaScript logic into the Python logic, no problem. Okay. So that is how our polyglot interop works. Now, just to stretch the imagination here about what you can do with this, polyglot interop does not depend on serialization. So you can actually create a class in Python and extend it in TypeScript. That's fine. You can have a function that you call over borders that exchanges complex types. You don't need to have your types be reducible to JSON for this. Yeah. So any questions about polyglot before I move on to this next demo? Okay, good sign.
I had a question here just online watching this. You say this is polyglot. Can you support native, say, C, C++, Rust, Zig, Go? How do you do that?
So it's a little bit language specific because, and so the question for the room is what about native code, right? C, C++, Swift, Rust, Zig, Go, all of those things. A little bit of that is language specific because, for instance, Go has its own garbage collector that it imposes on the program. And so in that case, we would have two competing garbage collectors, and that's not going to work, right? So we need a variant of Go that delegates its garbage collection, which I don't think they've built yet. On the other hand, other implementations like PHP, we've web generated a PHP implementation for fun to see how that would go. We got pretty far, and that's not hard to implement. When you're talking about loading C code into Python or JavaScript, or like JNI, that kind of thing, that is supported. So we support C extensions in Python, we support JNI, we support loading Node modules, Node API modules, and we are considering embedding a C linker and compiler, which would give you a lot more power too. In terms of running native code, that is in theory possible because GraalVM has an LLVM layer for Truffle, which would mean that we can actually virtualize and execute this native code inside the guest context, but that's a little further out. Did that answer your question?
Yes, so basically it's easy to do native languages that don't have their own garbage collector like C, C++, Zig, or Rust. But Go, because it has its own, is going to be harder.
That's right. And I should also say that C#, Go, pretty much all the languages you mentioned are already tracked by the GraalVM team. There's a lot of demand to see that happen. In fact, I do think there's a research project out of Europe that implements a C# runtime on this as well, which is obviously pretty scandalous. So.
Okay, and to follow up, if you can do multiple languages and compile natively, can you do cross compilation? In other words, if I happen to be on a Linux computer, can I generate a Windows binary or a Mac OS binary, all with just changing the settings in some config file somewhere?
So I'm going to talk about something that's not released yet, but this is also some technology we built, and the short answer is yes. Later, you will be able to do that. Today, you can't. But this is a split that most tool chains can't fix, right? Like, unless you have full cross-compilation support, even a C tool chain is really hard to get working that way, right? If you want to be on Linux compiling for Windows, it's a nightmare in the status quo. Through a technology partnership that we have with an inventor in California, and I don't expect that anybody would have heard of her work. Here, let me see if I can bring this up. Has anybody heard of Justine Tunney? You have?
Yeah, she did. I think she wrote some did work on binaries that could run on Windows, Mac, or Linux.
Yes, it's called Actually Portable Executable. Here it is. Justine invented this technology, which is a binary format that is simultaneously a PCOF, a Mach-O, an ELF, a boot sector, so you can boot to it, all in one file, right? And so this means that you can build one Cosmo binary, is what it's called. That's one file and you ship it to Windows, Linux, Mac, doesn't matter, identical file, and it runs as a native binary. And we are adding support for this to native image, which will let us do that too. Yeah. So in the future, when we land that support, you can write a program in JavaScript and Python, whatever mix you want, native compile it, and the output artifact can run on any computer, period, end of sentence. Yeah. Now, we get challenged about this a lot, just for the meeting. Like, people always want to see Cosmo working, and we do have Cosmo demos. So if you want to try that, please come to me, and I'll send you some demo links. But because it's not finished yet, it's not on the presentation. So, cool.
So to follow up on that, have you looked at the Zig toolchain? Because its claim to fame is that it can do native cross compilation. I think it's got the Clang compiler built in, because that's LLVM and all of that. And so it can generate native binaries cross-platform.
That is actually our plan, same as Zig, is we're going to embed LLVM, which includes a compiler and a linker, right? And then the question is just, do you provide the right context and flags to that embedded compiler and linker so that it behaves as it needs to behave for each operating system? So the answer is yes. We are going to have that same feature that Zig has, and they've proven it's possible, right?
I'm impressed.
So there's another question, which is, what does the binary get big? And it does. So to facilitate multi-arch, we have to generate code sections in AMD64 and ARM64 both. So it is effectively a fat binary. The interesting thing about it, though, is the real question is, how much bigger is it, right? And native code is pretty small. And so Google Java format is one that we've already converted into a Cosmo binary. Just like I said, you can download that one binary on any computer. It just works, and it's 40 megs. So the answer is it's pretty tolerable. And you can also, if you know you're targeting, like if you're targeting servers, you know it's going to run on AMD64, then you can tell us to omit the ARM code sections. Yeah. Any questions from the meeting crowd? Cool. So I have one more thing to show you guys, and this is a very exciting demo. This is the newest stuff we've done. You guys are the second group ever to see this. Building a runtime is cool. Elide is very cool. You can use it today. It's pretty stable. But the world has sort of moved on from the concept of runtimes in some ways. Today, everybody's using coding harnesses. That's sort of their immediate connection to their code is through Claude or Codex or any of these tools. The problem, though, is that these tools are not very good at debugging or being senior engineers in general, right? Like, the reason for that is that the coding harness has to brute force its way through your code. It has to grep around and invoke external tools, and sometimes those tools can't be found or they misbehave, and then it goes in circles trying to figure out what version of Python's on your system before it can generate and run code. So what we've done is we've created a coding harness. So this is something you use instead of Codex or Claude Code, and it embeds the runtime in the harness. This is very cool because all of a sudden, the harness gains these innate capabilities to generate code, run code, check code, format code, all as actions built into the harness. So this is actually at a deeper, more fundamental level than, say, MCP. Right? MCP invokes as an external tool. This is actually part of the runtime or the harness. So this is called Aura, the working name, which is just the first thing that came to mind. And in this case, the runtime is the harness. They're innate actions, right? So it's actually not invoking things through your shell. It's just calling itself internally to run it. And you still have that one binary guarantee, which is great for agents. Agents love Elide because it has all the tools built in. Agents, you know that long list of commands I showed earlier, right? Like, I can't even fit all of them on one screen. There's so many tools. And this would be a little imposing for a human. But for agents, they don't care at all. They love that. They have like, you can have 1,000 subtools, they would be happy. So I'm going to show you guys Aura. Let's go to space. So here's Aura. I've just started it. Yeah, V000. It's very new. Now, we would, same as our position in Elide, where we don't invent new APIs for you. This is going to be a very familiar demo. Our coding harness feels like Claude Code, and that it's intentional. We don't want to replace how these things work fundamentally. But here I've got my prompt. I've got it connected to GPT 5.6. Oh, you guys can't see that. It's in the corner here. And so I'm going to say, generate and run some Python for me, maybe a hello world or something. See how it just says run? It didn't search around my disk for Python and like have to look for UV or something and like go, oh, this is Python 3, not Python 2. I need to switch my syntax, right? Nothing. It can just run it in the harness. And we can do that too with any of the languages that Elide supports. So it's also much faster because all of the performance gains that Elide gives you naturally, you now get in your harness. So this harness, brand new. If you want to download it and try it, come find me because we don't have a download link yet, so I'm going to need to send you one. But we actually already use Aura to work on Elide itself and Aura. It's like self-improving now, technically, by the standards of AI. And so it's going to get a lot better, a lot faster. And I will also say, Aura is a collaboration between us and a project called OhMyPy, which I don't know if you guys have probably not seen. Let me show you that. So OhMyPy can get you from 6.7% effectiveness on Grok code, which nobody uses Grok code, but just bear with me, to 68%. It's a 10x gain. It's a 10x gain in your model's efficiency and effectiveness, plus 61% less tokens. So for 61% cheaper, you can be 10x more effective purely by managing properly the context associated with your harness, right? That's all we're doing here. And so Aura is built on top of this in partnership with this project. They brought the harness, we brought the runtime, and that's going to be the product. Yeah. So we talked about that. I'll leave this up at the end, which has our install link. It's very easy. It's a curl command. Elide.sh is actually a domain. It's fun. It downloads from elide.zip, which is also a domain. Yeah, so I'll pause there for Q&A. Thank you, guys.
I'm not working on the stage.
Oh, yes. Yes.
I have a question if no one else does.
Sure.
So Maven has an opinion as far as how you should organize the directories and where all your resources are supposed to be, and it's all source main Java and all this.
Yep.
But one of the disadvantages of Maven is that it has an opinion. If your project doesn't fit the Maven opinion, then you end up fighting the tool and trying to configure it and twist and turn to try to make Maven do what you want. So does Elide force an opinion on how you should organize your development project as far as how the directories and everything need to be organized and the build order and things like that?
We take a position not to enforce conventions. But we do default to conventions. So for instance, in this Java sample project we have right here, if I ask for a tree, what it gives you is the same structure as you'd be familiar in Maven by default, just because that's what Java developers are expecting in most cases. That being said, if I look at our, if I look at our pickle file here, it's mapping our paths right there. So the fact that this is set up this way is just an artifact of the demo. You can set it up however you want. You can put your code in any directory. You can mix your Kotlin and Java sources in one tree if you want to. You can mix Python and TypeScript sources in one tree if you want to. We don't care, is the answer.
So I can just configure it however I want, and I don't necessarily have to follow the Maven convention.
That's right. That's right. But if you create a blank project in Java, we assume that you'll probably want the Maven convention. So that's what we give you, but it's completely under your control.
Gotcha. I like that stance.
Thank you. Sorry, say it again. So the question is, how do you import an existing project? The answer is we are actually adding support for pom.xml and package.json and the equivalent in Python. So if you have a pom.xml, you can just use Elide build anyway. You don't actually have to write one of these pickle files. We're adding that, yeah. Yeah, so the idea there is this is all part of the same theme, which is we don't want to disrupt your workflow, right? Like if we can deliver a native Maven, which we are working on, it's a little bit more complex because of plugins and all sorts of things. Then we will for sure be delivering that. Yeah. We're also going to have a project generator so that you can easily translate projects. But truthfully, the sample I showed you guys with Spring Pet Clinic, the way we put that together was I downloaded Spring Pet Clinic off of their website. I opened and expanded the zip, and then I told Claude, write me an Elide pickle file, and it did. And so, now with LLMs, they're very good at porting code. So that part you could probably do yourself with just a few prompts. Yeah.
You may have already spoken to this, and I apologize if I missed it. But how does this work with CI/CD pipelines? GitHub Action.
Yeah.
I can't really name it anymore, but
Circle and the rest of these. Yeah.
CI, something like that. Yeah.
So the question is CI. Well, how does this mix with CI and CD? The answer is, if you've ever tried to run Gradle in a GitHub action, you know the pain I'm talking about, right? And a native runtime behaves entirely differently, right? GitHub Actions is really meant for quick start, quick end commands. It's not so good at long-running JVMs. And so for that reason, we have a setup Elide action for GitHub Actions. And so it's just 2 lines like that, and you get Elide in your GitHub action. It's on your path, it's a binary like anything else. And so it's much, much, much faster in CI. That's one case where it's very clearly a win, right? Yeah.
So how much it costs?
It's free.
Enterprise.
Well, so I will say we have a pricing page, and you guys should ignore it because we're changing our pricing. But no, the price is you have to join the Discord and start the repo. And otherwise, it's free. We do have 2 enterprise pilots now with logos that you guys would recognize. Can't talk about them publicly yet, but companies, before they adopt something this radical, they want to know that they can call and strangle me over the phone, right, if something breaks. And so that's what they're paying for. No individual developers are being asked to pay for this anymore. Yeah. Yeah. Cool. Any other questions? By the way, you don't actually have to join the Discord. Like, we can't enforce that. So you could just download it and use it if you want,
Have you tried asking an agent to enforce it for you? Or the enforcement mechanism?
I mean, if we really wanted to be, annoying about it, we could make you post something, or make you get a license key in Discord that you have to put in, or something. But if you're going to just download this in CI, you don't want to have a license key you manage and a secret and all this crap. It should just be a binary on your computer, right? And so we've decided we're going to make our money somewhere else. The runtime's free, the harness is free, and we're probably going to charge for support for now.
What's the token? I've opened about running an EC2. You can save my tokens by using this.
So I don't think, I'm actually not sure how we would plug into OpenClaw yet. It probably has a plugin architecture of some kind, right? If that's the case, then probably yes. Yeah, we will be making plugins for Codex, Claude, VS Code. You know. Yeah. Mm-hmm. Yeah.
Do you know how they're saving?
Yes, it's a mixture of many techniques, and this guy who wrote OMP, who is in the Netherlands, his name's Can, and we're partnering with him. He has a blog where he's explained a lot of these techniques, and so I'll show you just one of those, which is a technique called snap compact. This essentially, by storing your context as an image and using OCR to read the context, it's actually substantially more efficient and effective. So the phrase, and he jokes about this, the phrase "a picture is worth 1,000 words" is like literally true with LLMs. And I actually don't know if we know why quite yet. And he's experimenting with how big does the font size need to be in the image to be properly recalled, and what's the recall gain or loss. But what we see so far is that you get the same recall with basically no loss in quality, but for substantially cheaper. Yeah. Any other questions? Cool. Well, I will be here after to hang out with you guys, and thank you very much for having me.
I have a question.
Yes.
As far as documentation goes, what do you have? Do you have any tutorials? Do you have any reference documentation? Maybe it's on your website. Where do we look?
So if you go to elide.help, this is our documentation. And we've got installation, toolchain, runtime stuff. We've got full guides for all of our features. We just added an API reference too. So this covers everything in like JavaScript and Python that you could use, right? Obviously, the Java implementation is just the core JDK libraries that you're used to. So that one doesn't need a dedicated doc yet. But yes, go to elide.help. We are redesigning this right now to make it even better. So please, if you can't find something you want to know or get stuck, tell us in Discord and we'll fix it like the next day. Cool.
All right. Thank you.
Thank you, St. Louis JUG, for having us. Yeah.
Okay. All right.
I'm going to close my laptop now. Let's see.
Okay.
Hold on.